Study Section 12 Expectations, Consumption and Investment. Introduction. In Chapter 2, we pointed out that consumption and saving are determined essentially by current income. Our understanding of the expectation shows that current income is not the only determinant current consumption, but also expected income, expected inflation, etc. In your 300 level, you learned about some theories of consumption such as permanent income, absolute income, and life cycle income. You remember that permanent income hypothesis tells us that consumers plan their consumption not only on current income but also on the future income. In the case of life cycle, the central message is that agents plan their consumption over their lifetime. Thus, it is time to relax the assumption that consumption depends on current income only. In the case of investment, we have established the fact that expectations are a guiding principle to investment decisions. Thus, this chapter examines the role played by expectations in both consumption and investment. Expectations and consumption. Assuming that you are thinking of how much to consume over a given period of time. Of course, such consumption depends on the total value of your net wealth. This wealth can be collapsed into two: the human wealth and the non-human wealth. The human wealth is the compensation of your labor, income, or wages net taxes. The non-human wealth include bequests, stocks, bonds, money in banks, gold, and so on. Assuming that it is possible to estimate how much your total wealth will be for the rest of your life, it will be possible to calculate how much of this total wealth you will consume each year over your lifetime. Let A represent the proportion of total wealth consumed in each year. Thus, in year T, consumption Ct will be a fraction A of your total wealth Wt, that is, holding constant total wealth. An increase in A will lead to borrowing if consumption will increase. Let us be formal a little bit, assuming that total human wealth, labor income in year T is Yt, while tax deductible is Tt. Thus, expected income and expected tax will be and respectively. Now, let non-human wealth be N, which can be collapsed into financial wealth, bond, stocks, shares, bank deposit, and non-financial wealth, land, housing, and other properties. The component of total wealth will therefore be equations 12.1 and 12.2 tell us that a consumer who thinks of how his future will likely be decides to smoothen his consumption over time. The equations say that a very foresighted consumer computes all his wealth, equation 12.2, and consume a fraction of it, equation 12.1, each year. How reasonable is this model? Let us use a simple example to examine how plausible or otherwise the model is. Of course, you need to pay tax. Let us assume that you will pay 10% of your basic pay as tax, although you should have owed some people in the course of your study, and it is also true that you will possess some belongings. Let us assume that your total belonging is just enough to offset your total debt. Thus, your non-human wealth is zero. Hence, your total wealth is equal to your expected human wealth net expected income tax. Using our framework, you need to compute your expected human wealth. Equation 11.7 tells us how to do this, and we employ it here. This equation says that your net income is 90% of each year's income, with the hope that on average your salary increases by 2% annually. We can easily compute the present value of expected net income using equation 11.10 as follows, which means your total after-tax wealth of your lifetime is around 1,529,916. How much should you consume yearly? Let us assume that you will live for 90 years. First, you should be 57 years when you retire. Now, assuming that you want to maintain a constant level of consumption over your lifetime, the amount to consume every year should be your total expected wealth divided by your expected lifetime, that is 1,529,916 divided by 70 is equal to 21,855.94 kobo. Thus, for the remaining 2 years before you are employed, you will have to borrow 21,855 naira 0.94 kobo each year, and later you will start saving so that when you are retired, you will be spending the saving 21,855.94 kobo each year, no more, no less. How plausible is this model? First, how are we sure that one will live up to 90 years or not live beyond 90 years? What if there is sudden jump in income? Of course, income is downwardly rigid. What happens if there is unexpected expenditure? What about changes in economic policies? Why should you save up to 21,855.94 kobo? Why must you maintain a constant consumption? All these questions tend to cast doubt on the plausibility of the model. It thus appears that current consumption tends to depend on current income rather than expected future income. Thus, we need to modify our consumption function by assuming that current consumption depends on current income and also on total wealth as defined in equation 12.2. The issue now is how much consumption depends on current income, expected future income, and non-human wealth. This is an issue that cannot be theoretically settled. This is because consumers are heterogeneous in terms of consumption, access to credit, and earnings. Some consumers have low income and do not have access to credit. This set of consumers will rely only on their current income. Our model assumes that you will get a job immediately after National Youth Service Corps. This may not be possible for some. In fact, some may remain unemployed for more than 5 years before getting a job. During the triad unemployed period, it may be difficult to borrow money to maintain the level of consumption. Thus, this type of consumer will live on transfer, maybe from parents, friends, or family. Hence, his parent consumption does not depend on present rather than future income. Part B of Section 12. Income expectations and consumption. What we have discussed shows that consumption is not likely to respond to changes in income on one-for-one basis. In particular, consumption responds partially to changes in income. If consumers think that increase in income is permanent, they increase consumption. If they think that increase in income is temporary, they may not likely adjust consumption. This implies that during booming period, consumers do not fully raise consumption because the boom may not last. Conversely, when the economy is in recession, consumers do not fully reduce consumption because they know that the recession will soon peter out. Another fact that we can deduce from our analysis is that even if income does not change, consumption will change. For example, If an eloquent politician promises to deliver very well when he gets to the office, given the credibility of that politician, people might increase their consumption even when current income has not risen. Expectations and investment. Firms make investment in order to make more profit. Thus, the decision to buy new investment depends on the stream of profit that can be realized from the use of the machine, say, over its lifetime. If the present value of expected stream of income is less than the cost of the investment, the firm will not buy that investment. Thus, decisions to invest depend on expected profit. How will firms take decision whether or not to invest? First, they need to think of the lifespan of the machine. Some machines will last longer while some will not. The ones that last longer, the more years they spend, the less reliable they become and the more expensive they become to maintain. The second step is to compute the present discounted value of profit of the machine. Let the profit generated by the machine be, if the firm purchases new machine this year, we will assume that the machine will not work immediately because it has to be erected and tested be put into use, and this may take some time, say a year. This implies that the first expected profit will be generated in year T plus 1. Let represent this profit. The present value of the expected profit in year T plus 1 will then be, in year T plus 2, the machine will start to depreciate. Thus, in year T plus 2, the present value of the expected profit becomes, for many years, the present discounted value of expected profit of the machine becomes. The equation says that the expected present value of stream of profit is the discounted value of expected profit of next year, 2 years, and hence, and so on. The third step is to decide whether the investment is worthwhile or worthless. How do we do this? The firm will compare the solution value of equation 12.5 with the price of the machine. If the value is greater than the actual price of the machine is worthwhile and should be bought. If the value is less than the actual price of the machine, it is worthless and should not be bought. Generalizing the formula, we can use the idea developed for one firm, one machine to the entire economy. If aggregate investment in a year is denoted by IT and the profit per unit of investment is denoted by theta t, while the expected present value of stream of profit is, thus aggregate investment function becomes. This equation says that current aggregate investment IT is an increasing function of the expected present value of stream of profit of that investment. If the expected profit increases, aggregate investment will also increase. Note that in equation 12.5, interest rate and expected interest rate is inversely related to expected profit. The higher the interest rate, the lower the present value of stream of profit. This is another way of showing that interest rate is an important negative direct of investment. Now, assuming that interest rate is expected to remain the same over time, this implies that the expected interest rate next year, next 2 years, next 3 years, and so on is the same as this year's interest rate. That is, equation 12.5 then becomes, can easily factor out 1 over 1 plus IT in bracket theta t. Equation 12.8 follows a geometric series, a series of 1 plus x squared plus ... into bracket. In our case, x is equal to 1 minus delta in bracket over 1 plus IT in bracket. Hence, we have That is, if interest rate is fixed over time, the present value of expected stream of profit is equal to the product of the discount factor given by 1 over IT plus delta in bracket and the profit of the machine. If we substitute equation 12.9 into equation 12.6, we have the discount factor of equation 12.9 comprises two components, the interest rate and the depreciation. These two variables sum up to what is called the user cost or the rental cost of capital. We can also call it the shadow cost. In the case of Nigeria, this is actually the situation. As figure 12.1 shows, corporate profit and gross capital formation moved in the same direction in most years, particularly from 1990 to 2000 and from 2004 to 2009. However, some economists argue that current profit matters for investment more than expected profit. It was found that firms with highly profitable investment invest too little because their current profit is low. Firms with high current profit tend to invest more on projects that do not guarantee high profit. Consumption and investment volatility. From the behavior of consumption and investment to current and expected situation, it is clear that both current and expected income affect consumption, while current and expected profit affect investment. However, there is a notable difference between consumption and investment. How? When there is a permanent change in income and sales, consumption and investment respond to such change at different rates. When consumers view increase in income as permanent, the best they will of it to increase consumption by a full percentage increase in income. That is, if income increases by 100% and it is permanent, consumption will also increase by 100%. It cannot be more than that, because if it is more than that, consumers need to borrow to offset the difference. On the other hand, when sales increase permanently, the present value of profit also increases, and firms can increase investment even more than the percentage increase in sales. To fix idea, assuming that there is a large increase in the demand for university education and this increase in the demand is seen as permanent, university owner may decide to build classrooms, introduce new faculty, department, or new programs. The percentage change in investment can be more than current demand, but over time, it will return to its normal rate. Summary. Contrary to what we understood about consumption, current income, expected income, and non-human wealth are core determinants of consumption. The degree of responsiveness to consumption to changes in income depends on whether the change is temporary or permanent. Consumption responds partially to changes in income, but it may change without any change in income. Investment depends on both current and the present value of stream of profit. If interest rate and depreciation rate are permanent over time, investment depends on the product of shadow price and the profit of the investment. Investment depends positively on the level of income output earns. Investment depends on current and permanent output. Investment is much volatile than consumption. This is the end of study section 12. Thanks for listening.